To the Text Study channel. In the previous class, I have explained about third important question and its half answer. So that is what is data model and example and data relation, data semantics, consistency constraints and types of model. I have explained hierarchical model, network model and data model. So and in the model we have discussed mapping cardinalities also. So remaining left out topics are relational data model, NoSQL document data model, flat data model, object based data model. So before going to into these topics, we have to understand the relationship types of the relational data model. Means relationship type means mapping cardinalities of the relational data model. So we have seen mapping cardinalities in a entity relationship data model, but these mapping cardinalities of ER data model and the mapping cardinalities of relational data model are somewhat different. Meaning means almost the same, but due to the model diagrams, different model diagrams, we have to redefine the relationship types, means mapping cardinalities in the relational data model. So in this class we will see what is relational data model, definition and the relationship types, means mapping cardinalities. So what is relational model? Relational model, it manages the complexity of physical implementation, because relational database, the database in the relational database, the database is as the collection of tables in which the data is stored. And DBMS we already know, DBMS system also stores the data in the table format only. So in the relational model, we also storing the database as the collection of tables. So it reduces the complexity of physical implementation, means easy for physical implementation. And tables are also called relations and contains attributes which are characteristics of table. So here attributes means properties of entities. Entity mean the real world thing about which we want to give information. So example, if a student is an entity, then their attributes will be age, gender, branch, etc. And the attributes, the entity represents the table name and attributes represents the column names, okay, in the table. And tables are related to each other through same shared attribute. Here tables are related to each other through same shared attribute, means same through same column. If consider student table is there and course table is there, so it has a student name and student ID, and it has course table has course ID and course name. So here student ID column values and column ID column values are same. So these two column values in both tables, student table and in the course table, are same. So we make this student id in the first table as primary key, and in the second table course id we make it as a origin key. So the tables are related to each other through the same shared attribute. And then table relationship types is shown in the relational schema. Relationship type, okay, is shown in relational schema. So what is relationship type means? Mapping cardinalities is shown in relational schema. Okay, relational schema gives the it defines the columns of the table, so through which we can define our relationship types. Okay, means how the these two column names, student id and course id, are defined in the two tables. Okay, so next this remaining relational data model nodes I will explain in the next class. So as of now in this video I will explain relationship types only. So relationship types. So relationship types, the logical association among tables are called relationships. So relationship types, mapping cardinalities, which are also called mapping cardinalities. So defines how different tables connect to each other. Defines how different tables, okay, connected to each other, or the number of associations between two tables. Okay, so the number of association between two tables, it is physically shown in relational schema. Okay, using shared columns called primary keys and origin keys. Okay, relational schema. What is relational schema? A relational schema is the blueprint or visual skeleton of database. Okay, it defines the structure of the data by outlining the names of the tables, their columns, the data types of those columns, and the constants. So here it describes the columns also. Columns means here they describe the columns also. So through which we can relate two tables. Means columns means what? Attributes through which we can relate the two tables. Okay, so a relational schema is the blueprint or visual skeleton of database. It defines the structure of data by outlining the names of the tables, their columns, the data types of those columns, and the constraints. Okay, and then so it physically shown uh, in a relational schema using shared columns called primary keys and origin keys. So these relationships, okay, will be shown in this relational schema here using the primary keys and origin keys. Okay, so how they are related we will see now. How relationship types are shown in a relational schema. So instead of drawing lines between tables, like ER data model, a relational schema represents relationships explicitly through matching data. Okay, here in the ER model, we can see that these lines are representing the relationships, means this rhombus. Okay, so here instead of that A relational schema represents relationships explicitly through matching data. So what is matching data? So here primary key and foreign key. So matching data is primary key and foreign key. So a unique identifier for a specific row in one table. Okay, a unique identifier for a specific row in one table. Example, student ID in a student table. Okay, so this is the column name. Okay, so it is indicated by underline. Okay, a unique identifier for a specific row in one table. Okay, and then for region keys, a column in a second table that matches the primary key of the first table. So for region key, a column in second table that matches the primary key, okay, of the first table. Means through this statement, what we can understand that in two tables, primary key column and for origin key column is have the same values, okay, and for origin key column can contain redundant data, means duplicate data. If 101 is there, okay, it can contain again 101, another 101, and so like that it can contain redundant data. By placing the primary key of one table into another table as a foreign key, the database establishes and shows the relationship type. Okay. Examples of relationship types. So first we have four types of relationship types. One is one to one relationship type, one to many relationship type, and many to one relationship type, and many to many relationship type. So one to one relationship type is we have seen in ER model also. In ER model and relational model it will be same, but the concepts, means the what we called representation is different in both diagram, in both the models. So we have to redefine these statements in relational data model. So in relational data model, relationship types will be defined like this. Okay, so first one to one. Okay, each row in one table relates to exactly one row in second table. Okay, so here each row in first table relates to exactly one row in second table. That one row in other table, means second table, relates exactly that one row in first table, means vice versa. We are first defining one point and then we are converting into opposite statement. Okay, so we can understand this statement by using some example. Okay, so example is an employee and their parking space. So each employee has a specific parking space. Okay, and each parking space is specified to a particular employee. So that's the meaning of this statement, means each row in first table, means the example is employee, so relates to exactly one row in second table. So in second table parking spaces are there. So P1 will be the first parking space considered it. So employee 1 is relates to exactly one parking state P1. Okay, that's the meaning of this statement. And that one row in second table, means this P1 exactly that relates exactly that one row in the first table. So P1 is only specified to this E1 employee only. So other than him, no one can park the car at that place. So that's the meaning. And how it shows using primary key and four region key. So pk means primary key and fk means four region key. We place the primary key of one table as four region key in the second table. Okay, and set that four region key to be unique. So we will see through the example now. So example, creating table. Okay, we are creating a table. So column names are what? Employee ID and e name, employee name. So emp name means employee ID is primary key here. Okay, means which is used to join the two tables and create a table parking space. So parking space is a table name. We are creating table with this name. So space id, it is a primary key, space number, and employee id for region key. So here the employee id, here also in the first table employee id there, and the second table employee id there. Here it represents primary key and here it represents for region key. So those values will be, those two column values will be same for both the tables. And then so here we are placing the primary key of one table. So this table, primary employees table, primary key is employee id, placing in second table as for region key. So in the second table we are placing it. So here the employee table contains employee ID, EMP name, E101, E102, E103, and John, Sarah, and Mike. These are the employee names. Okay. And then parking table. Parking table contains space ID, primary key. It's a primary key of the second table, and then space number and employee ID for region key. Okay. So P90, P91, P92, spot A1, spot A2, spot B1, E101, E102, null. Okay. So here we are defining relationships. So spot A1 belongs to John. Okay. Uh, employee ID E101 belongs to which employee? We can see here John, and then Sarah and Mike. Okay, then and spot A2 belongs to Sarah, and spot B1 currently empty. So here we can observe that each employee is assigned to a specific parking space. Okay, and then noticing how the four region key constraint. So here we have said that uh, in the definition we have said that set the origin key to be unique. So why we have said that this is one to one relationship, that's why we have said to set the origin key as unique. So why means only one table relates to exactly one row. Okay, first table one row should be exactly relate to one row of second table, and second table one row should exactly relates to one row in the first table. So here if we duplicate it, E102, if I duplicated E102 and some spot, okay, some spot A3, so it forms a different relationship type. Means many to uh, if a spot is A2, here spot is A2 and here spot is A3. So here if I write E103 So here if I write E103, then it will become other relationship type. So next, noticing how the Phrygian key constant on the Phrygian key enforces a one-to-one relationship. Uh, meaning an employee can only have one primary parking space, and a parking space can only belongs to one employee. And then employee ID for region key is must be the unique primary key. Okay, this one. Okay, unique, it must not be duplicate. And then space ID is the primary key in the uh, parking table. Okay, and in employee ID is the origin key in the parking space table, linking back to the employee table, employee ID. Okay, this one. Okay, which is the origin key in the parking space table, linking back to the employee table. And a value can't be repeated in this column for region key. And if we try to add a new row like P93 here, P93 spot B2 and E101, the database would reject it. Why? Because E101 is already assigned to P90. Here E101 is assigned to P90. Okay, if we assign this employee ID to a new space ID, means parking space, then the database would reject it because it is already assigned to P19, and the unique rule stops his or her ID from appearing in the column a second time. It will appears in the student employee ID column. So only the employee can only have one parking space, and a parking space can only belongs to one employee. So this condition is not followed, so that's why it is rejected. And one to many, 1:n. So each row in the first table can relate to multiple rows in the second table. And but each row in the second table relates to exactly one row in the first table. So example is one department can have many employees. So here first table indicates department table, and second table indicates employee table. So one department means each row. One department means assume that CSC in the first table, which is department, can relate to multiple rows in the second table. So second table is employee table. So multiple rows are employee E1, employee E2, plus so on. But each row in the second table, the employees in the second table relates to exactly one row in the first table, which is department. Okay. So example, creating table departments, column names, department id, primary key, department name. Create table and another table we are creating, create table, employees, employee id, primary key and employee name, department id for region key. So table department is department id and department name, columns are there. Department id is a primary key. D10 and D20, department name is HR and engineering. Okay, and then employee table. So in the employee table, employee id is there, employee name and department id. These three columns are there. So E101, E102, E103 and E104. Employee IDs are there, and employee mean John, Sarah, Mike and David. And department ID is D10, D10, D20, null. So the relationship is John works in HR. So here John works is assigned to D10 department, which is the HR department. Okay, and then Sarah also works in HR and Mike works in engineering. And David is a new hire, not assigned to a department yet. Noticing how the for region key constraint on the for region key enforces a one many relationship. So here we have seen that each row in the first table can relate to multiple rows in the second table. Here is the first table department and second table is there. So this is the first table column. Okay, so each row in the first table can relate to multiple rows. So here the each row is first table, one row is D10, which is related to John and Sarah, both means multiple rows of second table. And but each row in the second table relates to exactly one row in the first table. Each row in the second table, this is the second table, each row relates to exactly one table. This both rows are related to only one row, that is D10 of the first table. Okay, and Mike is related to D20. Means we have to consider one to many and many to one. Means here in the one to many we have seen each row in the first table can relate to multiple rows in the second table. So here in the first table, D10 one row means each row is related to multiple rows in the second table, that is John and Sarah. And next means here one to many relationship is there, one to D10, one to many, John and Sarah. And in the next statement, each row in the second table relates to exactly one row in the first table. So in the second table, each row is related to exactly one. Okay, exactly one department. Okay, means one row. John is one row, means it can't be John can't be appointed for both departments, D10 and D20. It can be appointed to only D10 only. Okay, and then noticing how the origin key constant on the origin key enforces a one many relationship, meaning a department can have multiple employees. These and but employees can only belongs to one department. An employee can belongs to only one department, not more than one. Okay, like D20, D30, not like that. So then department ID for origin key in the employee table is not unique. So these are not unique. It is repeated to form one to many relationship. Okay, and it can be duplicate. This allows multiple employees to share the same department. So John and Sarah are the two employees which shares the same department D10, and employees to share the same department. Okay, and then employee ID is a primary key in employee table. It is employee ID is a primary key in the employee table, and employee department ID is the origin key in employee table. Department ID is a origin key in the employee table, linking back to the department table, to this table. Okay, and then values can be repeated in this column for origin key, creating the many side. Okay, and then D10 appears only once in the departments table. Here the D10 appears only once in the department table. Here the department table, unique primary key values are there. Okay, in the department ID column. So D10 appears only once in the department table, but it appears twice in the employee table. Here D10 and D10 in the employee table, assigned to both John and Sarah. So each individual employee row holds only one department ID at a time. Each employee holds only one department ID at a time. So if we try to add a new row like E105 John D20, the database would reject it. Why? Because John is already assigned to D10. Here John is already assigned to D10. We are writing here John and we are writing here D20 and here E104. So John is already assigned to D10. So in the one to many relationship, an employee can only belongs to one department only, not D20 and D20, because here in the definition it is there. Each row in the second table means in the employee table relates to exactly one row in the first table. So that is department table. That's why this condition is not satisfied. Okay, and then it breaks the employee rule, means an employee can only belongs to one department. That rule, it breaks it. That is, John can't belongs to both or multiple D10 and D20 department in this setup. Okay. Here remove this one. Okay. Both D10 and D20 departments in the setup. And then so in case of one-to-one relationship type, E101, it appears only once in the employees table and in the parking space table. E101 only appears once in the parking space table and in the employee table. Okay. Assigned to P90. Here in the parking space table, E101 is assigned to P90 space ID. Okay. Each individual employee row holds only one parking space. Each individual employee row holds only one parking space, and each parking space row holds only one employee. Means this individual employee means a person is exactly holds the one parking space, and it can't hold a spot A2 also. That's the meaning. Okay. And each space is holds only the one person. Okay, not E2 E102 person also. Okay, no, only the E101 person. Okay, then many to one relationship type. Each row in the first table can relate to exactly one row in the second table. But each row in the second table relates to multiple rows in the first table. It is totally opposite to the one-to-many relationship type. Okay. So example is many employees belongs to one department. So here the first table is employees and second table department. Each row in the first table means in the employee table E1 employee, okay, can relate to exactly one row in the second table. So only assigned to D1 department only. Okay. And but each row in the second table relates to multiple rows in the first table. So and D1 can contain many employees. Okay, department 1 contains many employees, E2, E3, okay, like that. That's the meaning of these two statements. And then here this how it's shown using a primary key and for region key is same for both one to many and many to one relationship. So here we take the primary key of the one side, so in the one to many we take the primary key of the one side, department ID, in the department tables, and put it as a for region key in the many side, department ID in employees table. Here the one side is department ID and many side is employee table. Department table is one side and employee table is many side. So primary key of one side, this department ID, we have put it in the employee table many side, and in the many to one relationship also we are doing the same. Okay. So creating table, department table. Here we are first taking department table and next we are taking employee table. Okay. Create the table departments. Column names are department ID, primary key, department name, and create table employees, employee ID, primary key, and employee name, department ID for region key. So here department ID and department ID, both columns values will be same in the two tables. Here department table is department ID and department name, D10, D20, HR, engineering, and employee table. So employee table contains employee ID, employee name, and department ID. E101, E102, E103, John, Sarah, and Mike. D10, D10, D20. And relationship. John relates to exactly one department, HR, and Sarah relates to exactly one department, HR, and Mike relates to exactly one department. Noticing how for region key constraints on the for region key enforces a many to one relationship, meaning multiple employees can points to the same or one department. So John and Sarah pointing to same department, and a single department row can point to multiple employees. So this D10 points to both employees. Okay. If we observe here, in the many to one, multiple employees can point to the same department, and single department row can point back to the multiple employees. So in the one to many, a department can have multiple employees, and but an employee can only belongs to one department. So this is totally opposite statement. Okay. Means we are first statement goes down and second statement goes up. So we got the many to one. Okay, many to one relationship type. And then department ID for region key in the employee table is not unique. So here we can observe not unique means duplicate values. Okay, it can be duplicate. This allows multiple employees to share the same department. Multiple employees, same department. Okay, and then employee ID is a primary key in employee table. Employee ID is primary key in the employee table, and department ID is the origin key in employee table, linking back to the department ID, department table. Department ID is a origin key in employee table, linking back to the department table. Okay, and then values can be repeated in this column, creating a many sites. Okay. Then D10 appears twice in the employee table. Employee table, it is twice it occurs, and it up each and it appears only once in the department table. In the department table, it appears only once, D10. Okay. Each individual employee row holds only one department ID at a time. Okay. Here. Each individual employee row holds only one department ID. Okay. So, if we try to add a new row like E104 John D20, the database would reject it. Why? Because John is already assigned to D10. And it breaks the department rule, that is D10, D20 can't points to one or same employee. Here we have seen a single department row can point to multiple employees, but here multiple department IDs are pointing to same employee, so that's why it is rejected. And then many to many, each row in the first table can relate to multiple rows in the second table, and each row in the second table relates to multiple rows in the first table. Example, students and courses. So example is a student takes many courses and a course has many students. And many records in one table relates to many records in another. So this is the another definition of many to many relationship type. And then we can't establish this directly. We must create a third table, often called junction or linking table. This table contains the primary keys from both original tables as 4 region keys. So by example we can understand it. So create table students, student ID, column, primary key, student name, and course table. Create table courses. Course is another table, and course ID and course name. And enrollment, student ID, course ID, both are columns for the enrollment table. Together these two acts as a primary key for the enrollments table. This is the student table and course table. Student ID, student name, S101, S102, S103, A, B, C, and course ID C201, C202, Maths, CSC. So enrollment table will be student ID, course ID, for region key, S101, S101, S102, S103, C201, C202, C201, C202. So relationship is A is in Maths, means student name is A is in Maths, and A is also in CSC. So here relationships are A is in Maths, A is in CSC, B is in Maths, C is in CSC. So one student is enrolled in multiple courses, and Maths course is enrolled by multiple students, A and B. Okay, and then noticing how the enrollments table uses the values from the first two tables to create the many to many relationship. Student ID is unique. Primary key, student table, and course ID is unique primary key and course table. Here we have primary key in both tables, student ID and course ID. And then student ID and course ID are 4 agent keys linking back to the tables above. Enrollment table contains the 4 agent keys, student ID and course ID. So together they form a composite primary key. So this means the combination of both IDs must be unique, preventing a student from enrolling in the exact same course twice. Okay, and then multiple students can be enrolled in multiple courses, and multiple courses can be enrolled by multiple students. Okay, as I have shown there. And origin keys must be duplicate to create many sets. These student IDs and course IDs must be duplicate values to create many sites. Okay, so that's it for today's class. If you feel this video is helpful, then like, share, subscribe and comment it. If you have any doubt, ask in the comment section. I will see you in the next class. Thank you. Bye.